All right, this is your Unit 2 review. So, domain is your x values, and range is your y values. So if you're going to do the domain for a data set from a table, you're just going to list all of the x values from lowest, least to greatest in order. The range is your y values, so you're going to list all the y values from least to greatest in order. And remember, use the bracket notation. That's all you would have to do. So number 2, they're asking about the domain and range for a function that's graphed. Now, for the domain, remember you're going from furthest left to furthest right. And I think we would all agree that this is getting wider and wider as we go in the x direction, okay? Because domain is only looking at x. And so because these arrows means it goes forever, we're getting wider and wider in both left and right. So the domain of this would be negative infinity to positive infinity. I'm using parentheses because while the function approaches those infinity terms, it will never reach them. The range are your possible y values. And so this is saying, I think we would all agree that it's going down forever. So the lower bound is going to be negative infinity. Sorry, that infinity is terrible. Okay. The upper bound, so remember, we're only looking at the y values here, is at y equals 2. Because that 2 is included in this function, I'm going to use a bracket to close that off. All right, so now I'm going to do one of every type of problem just to give you an idea of what you're going to see. So I'll do this over here where I have more space. So this is asking about finding the slope. So read these carefully. I'm not asking for any equation of a line, just the slope. So it's y2 minus y1 over x2 minus x1. So here would be x1, y1, x2, y2. So we can do 5 minus 9, right? y2 minus y1 over 7 minus 3. x2 minus x1. So that ends up being negative 4 over 4, which is negative 1. So that's the simplest form. The slope is negative 1. Okay, now here I'm looking at number 8. So they're asking us to graph a line with the equation y equals 3/5 x minus 4. This is in the slope-intercept form. So it's in the form y equals mx plus b. So this 3/5 is m. Then minus 4 is b. So b is our y-intercept. So I know that the y-intercept is at the point 0, b. And in this case, it would be 0, negative 4. So that's where I'm going to start, at the point 0, negative 4. So I graphed that right here. The slope is telling me how to move from the y-intercept. So the slope is 3/5. What that means is I'm going to go up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. 2 lines is enough to graph the line, 2 points is enough to graph the line. So then I'll put it in there. Now, if the slope were negative, I would go down 3, 1, 2, 3, but I would still go to the right 5. So that's the difference. If you have a positive slope, the line should be going up from left to right. So that's how you graph in slope-intercept form. Okay. You may be asked to write the equation of a line given the graph. So again, y equals mx plus b, where m is the slope and b is the y-intercept. So I know that b is equal to where the graph hits the y-axis. So it's right there at -1. And then I can choose 2 points to find the slope. So I will just go to the next point from the y-intercept. I go down 1 over 2. So m is equal to down 1 would be -1 over 2, so -1/2. So if I'm writing the equation for this line, y equals -1/2 x minus 1. So y equals mx plus b. All right, what's next? Okay, this one I might need more space. Okay, here they're asking, what is the equation of the line that passes through the point 6, 2 and has a slope of 1/3? So I'm going to move to Microsoft Word. So, and it specifies, write the equation in slope-intercept form, slope-intercept form. Great. Okay, so I have a point and I have the slope. So I can use point-slope form to get an equation for the line. So y minus y1 is equal to m times the quantity x minus x1. My slope is m. This is y1, or sorry. This is x1, this is y1. So the first thing we can do is plug those in. So I can say y minus 2 is equal to m, which is 1/3, x minus 6. So there I just plugged in x1, y1, and m. Now this is the equation in point-slope form, but we need to get into slope-intercept form. So what I'm going to do is, first step is distribute this 1/3. Okay, so after I distribute the 1/3, I end up getting y minus 2 is equal to 1/3 x minus 2. So I did 1/3 times -6 is going to end up giving you -2. Last, I'm going to get y by itself to be in y equals mx plus b. So I'm going to add 2 to both sides. And you end up with y is equal to 1/3 x plus 0. So that's our 1/3 x, or sorry, mx plus b. And you could write that as y equals just 1/3 x. So here we are in slope-intercept form. Okay. All right. So that's how you do those. All right. You may be given just 2 points on a line and asked to write an equation for that line in slope-intercept form. So there's going to be 3 steps to this. First, you have to find the slope using those 2 points. Then you write in point-slope form. And then we're going to convert or simplify to slope-intercept, just like we just did. So the points are 3, 6, and -3, 4. So I'm going to first find the slope, which is y2 minus y1 over x2 minus x1. So if I plug all those in, this is y2, so 4 minus y1 minus 6 over negative 3, which is x2, whoops, minus x1, which is 3. So I end up with negative 2, negative 3 minus 3 is negative 6, which simplifies to 1 over 3. So that's my slope. Now I'm going to use point slope form to write an equation for the line. So I'm just going to choose this point for point slope form. If you choose the other one, you're going to get the same answer. So remember, point slope form is y minus, whoa, that's bad. Okay. Y minus y1 is equal to m times the quantity x minus x1. So I can do y minus 6, right? That's y1, is equal to 1/3 times the quantity x minus 3. Okay, that's step 2. Now I'm in point slope form. Now I'm going to simplify or convert to slope-intercept form. So I'm going to distribute the 1/3. So you get y minus 6 is equal to 1/3 x minus 1. 1/3 times negative 3 is negative 1. And then I'm going to add 6 to both sides. So you get y equals 1/3 x plus 7. Whoops. Be careful with that. It's plus 5. Negative 1 plus 6 is 5. Great. So that's all. So then I convert to slope-intercept. So yeah, people get confused with that. So step 1 is find the slope using the slope equation. Step 2 is write the equation for the line in point slope form. And then lastly, you convert to slope-intercept form. Okay, so for this type of problem, you're going to get an equation in standard form, and you're going to be asked to find the x and y intercepts of the graph. And so we had said the x-intercept is where the graph hits the x-axis, so y is equal to 0. And the y-intercept is where the graph hits the y-axis, so x is equal to 0. So for each of these, if I want to find the x-intercept, I plug in 0 for y. So 4x minus 2 times 0 is 28. 2 times 0 is 0, so then 4x is equal to 28. 28 divided by 4, if we divide by 4 on both sides, so x is 7. Same thing for the y-intercept, except I'm going to put in 0 for x. So I have 4 times 0 minus 2y is equal to 28. 4 times 0 is 0, so negative 2y is equal to 28. I'm going to divide by negative 2 on both sides, and you end up getting y is equal to negative 14. Okay, this type of problem, so I'm going to look at number 33. When you see direct proportion, that's the same as direct variation, which means we're going to be using the formulas y equals kx and k is equal to y over x. So if they tell us x and y are in direct proportion, or that means direct variation, and y is 7 when x is 14, so when they tell us that, I can plug in when y is 7, x is 14, and we can simplify that to 1 over 2. So now I know k is equal to 1/2. Find y when x is 12. Okay, now we don't know what y is, but I know that k is 1/2. So now I'm using this formula up here, and x is 12. So now I can just calculate. 12 times 1/2 is 6. So y is going to be 6. So the first step is find k. And the second step is calculate y using the k that you just found. These are direct variation word problems. They're a little bit different than what we looked at in class, but you should be able to figure it out using the same strategy. So we could say a 6-inch candle. So we could say candle length is y, and we could say time is x. So k is equal to y over x, and we have a 6-inch candle, so candle length is y, burns in 3 hours. Time is x. So now our k value is 2. It's asking how long would it take, so they're asking about time, a 12-inch candle to burn down. So we can still use y equals k over, or y equals kx, but this time they're saying a 12-inch candle, so our candle length is y. So we can say 12 is equal to 2 times x. And then I can divide by 2 on both sides to solve for x. So x is equal to 6 hours. That would make sense if we double the candle length. So from 6 inches to 12 inches, we double the amount of time from 3 hours to 6 hours. But that's how you would figure it out. Okay, I'm going to do a couple of these. These might look intimidating, but it's actually pretty straightforward. So our parent function is the solid one. And then our transformed function is the dotted line. And so they're asking, what would the transformed function look like relative to the parent function? So if I were to ask you to describe in words what the transformation is, you should say it's moved left 1, and it's reflected in the x-axis. See how it's a mirror image and then moved to the left by 1. So the way that you can tell how far it was moved is choose a point on the original and then try to find that same point on the transformed function, and you'll see I just moved to the left by 1 there. Okay. So if I were to move to the left by 1, if you move to the left, you end up getting f of x plus h. And because I move to the left by 1, it should be f of x plus 1. And since f of x is x squared, it should look like x plus 1 squared. So anything not having that is not the right answer. Because again, we just plug that into the equation. So b is wrong. This would be moved to the right. The 1 isn't even in the parentheses. So the only possible answer here is A. Now, reflection on the x-axis, you just put a negative sign in front of f of x. So this is exactly right. All right, let's look at one more. So here we have y equals f of x, and it's a solid black graph. And we need to figure out the transformation of the dotted one. So I'm going to choose an easy to find point. So right here, I'm at -2, 0. And then that same point here is on the dotted line. So what you'll notice is that I'm moving up 1, 2, 3, 4. So I should see somewhere f of x plus 4. Okay? Anything without f of x plus 4, a and c are gone, because those are f of x minus 4. So now I have 2 to choose from. And so what you'll notice is that I'm moving to the right by 1. To move to the right by 1, I have to do f of x minus 1. So the final answer should be f of x minus 1 plus 4, which is b. So that's how you do those. You can kind of reason through them. Let me do, I can finish these. All right. So here I'm starting at the origin, and here's my new point, the vertex. So I'm moving to the right by 1. When you move to the right, that's f of x minus 1. Again, because I moved to the right by 1. So anything with f of x plus 1 would move to the left. So I'm going to get rid of the f of x plus 1s. And then I'm moving down 1, 2. So I should see f of x minus 1, then minus 2. So C is the best answer. C is the correct answer. Okay, last one. So here, I'm going to choose the vertex on both, and I'm going to move 1, 2, 3 to the left. Because I'm moving to the left, it would be f of x plus 3. And then I'm moving down 1, so it would be minus 1. So B is the best answer. Again, this says I move down 1. This says I move left 3. Okay, this one we are graphing a absolute value function. So you can use your calculator for this. Let me move it so you can see mine. So here's what we're going to do. Well, first off, let me look at the function. So it's 2 times the absolute value of x plus 4 minus 5. Here's how you would type that in. So you would do 2, and then to get to absolute value, I'm going to go to second 0. That's my catalog. So absolute value of x, I already forgot, plus 4 minus 5. So when I put that in and I graph it, what I'm going to do is I'm going to try to find the approximate location of the vertex by scrolling around with my arrows here. And so what you can see is that the x value, the approximate location of the vertex, again, that's where it changes direction, is -4, -5. So when I go to my table, which is second graph, I'm going to go to x is -4, and I'm going to plot the points, the point of the vertex, -4, -5, and I'm going to plot 2 above it and 2 below it. And what I mean by that is in the table. So I'm going to do -4, -5. So -4, -5. And then we can do the points around it. So that would be -5 and -3 and -3 and -3. So -5, -3, -3, -3. And then we'll do 2 more. So we'll do -6, -1, and -1. Where was I? -6, -1, and -2, -1. So -6, -1, -2, -1. So that's how you would use your calculator to graph that. You don't need to use your calculator. You can figure out how to graph it just based on the equation. So based on the transformations and translations we've been talking about, the -4 inside the absolute value says we're going to shift right 4 from the origin, and the +5 outside of the absolute value function says we're going to shift up 5 from the origin. So here I can move right 4, up 5, and that's going to be my vertex. The number in front of the absolute value function is the slope, which we call a. If there is no number, then a is equal to 1. So my slope to the right of the vertex is +1. So I can put a couple of points in, up 1, over 1. To the left, it's going to be negative a, so I'm going to go up 1 and to the left by 1. Up 1 and to the left by 1. And so my function is going to end up looking like this. So the absolute value of x is our parent function, and it's shifted to the right by 4 and up by 5. You can also put this in your calculator like I showed you over here. Okay. You also might be given an absolute value graph, and you have to write the equation for that. So remember, I told you y is equal to a times the absolute value of x minus h plus k, where the vertex is hk and the slope is a. So here, I can identify the vertex right here where we change direction as -4, -1. And I can identify the slope if we find another point where it goes right through the grid. So like right there, I'm going up 1, 2, 3, and over 1. So my slope is 3, or 3 over 1. So then when I'm writing this, I would say, hold on, okay, y is equal to a, which is 3, times the absolute value of x. Now we have to do it's x minus h, so we have to flip the sign. We have to do the opposite of whatever the vertex point is. So it's x plus 4 minus k, or sorry, plus k, which is -1. So I'm going to say -1. So that's how you would do that one. Okay. All right. Last thing is graphing inequalities. So there's a couple of different ways we can do this. It's easiest to have this in slope-intercept form. So what I'm going to do is I'm going to isolate y so that I'm in y equals mx plus b. So my first step is going to be subtracting 4x from both sides. So I get 5y is equal to -4x plus 25. I like to put the x term in front because it's y equals mx plus b. All right, then I'm going to divide by 5 on both sides. Remember, you have to divide all the terms on the right side by 5. So you end up with y is equal to -4/5 x. I always say pull the fraction out and then put it in front of the x, plus 5. But hold on. It's y is less than, and y is less than. So when you're graphing inequalities, don't make that mistake. Make sure that it's not equals, it's keep the inequality in the right place. So now what I'm going to do is I'm going to graph what's called the boundary line. So I'm going to graph this as if it's a line, like y equals mx plus b, but because it's y is less than and not y is less than or equal to, I'm going to make my line dashed. So this is my y-intercept. So I'm going to graph a point at 0, 5. And my slope is -4 over 5. So I'm going to go down 4, 1, 2, 3, 4, over 5. And that's going to be where my boundary line is going to be. So I'm going to make this a dashed line because, again, that line is not included in this function. Now what I'm going to do is I'm going to test a point, and the easiest point to test is the point 0, 0. And that's going to tell me how I should do my shading. So I'm going to say that x is 0 and y is 0. So that would be the point 0, 0 right here. And I'm going to plug those into this equation. So I'm going to say, we'll go over here. 0 is greater than, or sorry, is less than -4/5 times 0 plus 5. And so that gives us -4/5 times 0 is 0. So it says 0 is is less than 5, which is true. So that means that this point 0, 0 would be included in the function, and so you can shade everything on the side of that point 0, 0. Okay, we'll do one more, and I'm going to do the more challenging one. So 56 is in standard form. I think it's easiest to be in slope-intercept form in order to graph. So we're going to get y by itself. We're going to isolate y. So we're going to subtract 3x from both sides. So we get negative 2y is greater than or equal to negative 3x plus 2. I'm going to divide by negative 2 on both sides. Remember, this whole term needs to be divided by negative 2. And so then you get y. Remember, if I divide by a negative, I have to flip my inequality. Is less than or equal to 3/2 x minus 1. So negative 3 over negative 2 is 3/2. I pull that out and put it in front of x. And then 2 over negative 2 is negative 1. Next, I graph my boundary line. So my y-intercept is at 0, negative 1. And then my slope is 3/2. So up 3, 1, 2, 3, over 2. So we'll go right here. Up 3, 1, 2, 3, over 2. And because it's less than or equal to, I'm going to use a solid line because now this line is included in the function. All right. We can use our zeros test. So we can say, well, is the point 0, 0, which is right here, included in this function? So I'm going to say let x equal 0, let y equal 0, and we'll see if this inequality holds true. So I'm going to say 0 is less than or equal to 3/2 x minus 1, and x is 0, so I'm going to plug 0 in for x. 3/2 times 0 is 0, so 0 is less than or equal to negative 1. That is not true. So that means that this point 0, 0 is not in our function, which would mean that we would shade opposite of that.